All right, here we are, class, finally on the last lecture of lecture 3. That makes any sense. So we're finally to the point. The rest of this lecture, hopefully, will be pretty quick. We've talked about science and generating research ideas. Now we're going to talk a little more specifically about formulating our questions. So this graph here, figure, shows you the shape of an idea. And you can begin with very broad questions. And this is probably where you are at right now in your group project. You think you want to do something with dogs, well, because that's a requirement. And then you're starting to think about, what types of things are you going to look at in our data set? Are people who have active dogs more likely to be active themselves? Are females more likely to have cuddly dogs than males? All kinds of things you can think about. So you're thinking of a broad question, then you're going to narrow it down and make your specific guesses. And this is right where we are right now, kind of in between those narrowing down and operationalizing. And after you've narrowed down and before you operationalize, you need to state your specific question. And that's where our hypothesis is, and that's what we're going to talk about now. So let's talk about sources of research ideas. Where do your ideas come from? Well, a lot of them can just come from looking at your own life. You can just observe. There can be naturalistic observation and systematic observation. And you can actually do them on the same thing. And I'm going to give you an example of a research project that some of my students from Fresno State, actually, that's how long ago it was. Some of my students from Fresno State used, I think that they did a really great study. So naturalistic observation is just stuff you kind of noticed. And what they did is they noticed that when there wasn't a highway patrolman or a policeman present, people tended to run stop signs. They call it the California stop. You don't really stop and you just kind of go right through. So they noticed, but then they also noticed that when there was a cop present, people would tend to stop at the stop signs. So that's naturalistic observation. They're just kind of noticing, they think it's happening. They're not using any scientific principles. So all they can really say is, I noticed this. We can't count out bias. We can't count out that they're not defining stops the same way. We just kind of have a vague idea. Now, systematic observation is when you observe something with some rules in place. So you've defined what a stop is. A stop is at least 1 second. The wheels do not move and they're behind the line. Okay, so you've operationally defined. You're not just saying, stop. You're saying a stop is this specific observation of a car. All 4 wheels come to a stop. It's behind the line and it lasts at least 1 second, 1001. So systematic observation is looking at the same thing or anything really with some rules in place. There might be a specific time of day. Often, as we're going to talk about later, you have 2 people looking at it at the same time with the same definition so they can agree upon that it happened, which makes it more scientific. They've measured something with the definition that they can agree upon. And that's systematic observation. So what my students did was one of them, fortunately, had a dad who was a highway patrolman. So they all went to this stop sign that was a little bit out of town, and they sat in a tree, I think. They were young, and they were students. And they had my friend's dad park right on a side road so the people coming up could see him. And they counted how many people stopped. And they noticed that with their definition, and they saw that people really stopped. So that was systematic observation. They agreed upon what they were looking for. They wrote it down, they looked for it. So there's naturalistic observation, which is nice, but it doesn't really give us any scientific proof, and systematic observation. So when we have definitions, we can use that as evidence. When you've got a clear definition and multiple people can agree upon it, it's much, much stronger empirical evidence. So that's observation. You can get a lot of ideas that way. Some people get their ideas from theories. And I actually did my master's thesis on evolutionary theory, which makes a whole bunch of guesses about differences between males and females. And so I did my master's thesis on flirting. Don't laugh. And it wasn't that I was like a super flirty girl or anything. The actual thing was I just pretty much had my nose in a book. And somehow I thought that I would learn more if I'd learned flirting by studying evolutionary theory, which is a whole nother story. But it's a really good idea. It gave me some really good ideas for testable hypotheses. And I tested that males would be more likely to value physical attributes, where females would be more likely to value mental attributes when choosing a mate. And I was right. So also, research ideas, and this is one of the most important ways, I think, is the need to solve practical problems. So one problem, and I apologize if this is disturbing to you, is trying to get pregnant people to stop smoking. I know, and you know, that it's very, very dangerous for both the mother and the developing fetus, but we see it all the time. So one research project might be to find out why mothers are smoking or what types of strategies work to get them to stop smoking. So that's the need to solve practical problems. So your ideas, your questions must be important. They must be useful to somebody or something. And that they could be either directly important or important down the road. For example, we might want to know if dog owners have more self-esteem than non-dog owners. That sounds like kind of fun, but it could be down the line, it could be really important. If we know that self-esteem is associated with a lot of negative health things, and so we find out that there's something about dog ownership that can improve people's self-esteem, that's important research. They also must be answerable or testable, and that means they need to be a yes or no question. They're a statement that we can prove to be false. So for example, I might say, dog owners will have higher self-esteem than non-dog owners. That we can prove true or false. We can look at our data set, we can look and compare the self-esteem between the dog owners and the non-dog owners. Okay, and I'm going to say something here, and I'm going to say it again because it's super important. A lot of people try to put something extra into that hypothesis or into their research question. And they might say something like, dog owners will have higher self-esteem than non-dog owners because the dogs make them happy. Sounds like a good idea to me, but it's not a good question because it's not testable. Because if we haven't asked them if the dogs make them happy, or we can't measure how the dogs make them happy, then it shouldn't be in the hypothesis. The hypothesis of the research question's got to be directly answerable. No, we can suggest and offer some rational evidence that might be the reason, but it can't be part of our hypothesis because our hypothesis has to be testable. It has to be a true or a false. And then hypotheses are also empirical. They're answered by observation, hard observation, seeing something happening like the stop that I just described, or soft empiricism, and that's where we ask somebody a questionnaire, which is what we would do for self-esteem. And they also require operational definitions, and this is so important that I'm going to talk about this the whole next lecture, but for now you just got to know that operational definitions are something that is measurable, something that people can agree upon. So a formal hypothesis is a specific statement about the expected relationship between two variables. So that doesn't have any extra stuff. It's a prediction. So normally it goes near the beginning of the study and we're saying, hey, I predict that this will happen. Then you do the study and you look at the data and you can predict whether your prediction was true or false. So prediction's an educated guess. And I'm going to give you lots and lots of examples. Sometimes it's an if they then be form. So for example, if someone is a dog owner, then they will have high self-esteem. If someone is not a dog owner, then they will have lower self-esteem. And if it's not, it sometimes is a little bit easier for you to understand if you take whatever form that the study hypothesis is in, and the hypothesis is generally the last statement of the introduction section, or it's in the last paragraph of the introduction section. But sometimes you can take a look at their hypothesis, and if it's a little confusing to you, you can put it in an if A then B form and make it easier to understand. So here's a couple of examples. Students in classrooms that have pets in them will be more engaged than students who are not in classrooms that have pets. Or students in classrooms with pets will be more engaged than students who are in classrooms without pets. Okay, formal hypothesis. So I can test that. I can take two classrooms of students and I can put pet in one and not a pet in the other, and I can see who is more engaged. So if a student is in a classroom with a pet, they will be more engaged than the student in a classroom without a pet. Here's a second hypothesis. Consumers will be more likely to buy garments with washing instruction labels in them than garments without washing instruction labels. So I can test that. I can put a bunch of people in a mock store and I could have clothes with washing labels and clothes without washing labels, and I could measure how many they buy and compare, or I could ask them questions. So that's testable. Another example, and this is actually from a study. It was a study talking about people who have physical symptoms that go to the doctor and they can't figure out what it is. And there are a lot of things like that. And the symptoms are real, very real to the person, and they can lead to other things, but sometimes the doctors can't figure out what that is. And so these researchers turned to, guess what, our favorite attachment theory, and reasoned out that it could be something to do with the proximity, how they trust others, and the stress response. So they gave a long, complicated, rational introduction that was really interesting, but they said, in this study, we hypothesized that female medical patients with preoccupied and fearful attachment, or negative self-models of attachment, those were those high anxiety, I believe, would have significantly higher physical symptom reporting compared with patients who have secure or dismissing attachment. So basically, they were comparing the two attachment styles, and they could test that. They had a bunch of patients. They gave them attachment style questionnaires so they knew if they were preoccupied or fearful or secure or dismissing, and then they counted up their symptoms. Very testable statements. Or they could have shortened it and say, if a person has a preoccupied or fearful attachment style, then they will have more physical symptoms than people with other attachment styles. Totally testable. And it makes a prediction, right? You're predicting that you're going to look at the data and this is what's going to happen. So now let's try it. I've got a couple of ideas just to run it through you, and I'm not going to talk about anything new. So those of you who are tired of hearing about me can stop here, or if you understand it already. But if not, I'm going to run through a couple more examples. So I was thinking about this, and I thought a general idea. I was talking with a friend of mine who does financial management stuff, and that is that a rough childhood, being abused as a childhood, might be associated with less financial success. So I thought, that's kind of interesting. Maybe someone who has a bad childhood is not as good at staying with the job or getting educated, or and eventually they couldn't make money. So, that could be kind of interesting. So I need to take a look at that. So first of all, I would have to identify my two variables, and they were rough childhood and financial success. Those are the two things I'm looking about relationships between. And then I have to define them. And like I said, we're going to talk about operational definitions longer the next lecture. But I might define rough childhood. There are a lot of questionnaires that ask about, they're called ACEs, Adverse Child Experiences. So I might define rough childhood as their score on a test of ACEs. And then financial success, I might see how much money they make. So I'd looking at rough childhood by score on a test, financial success by asking them how much money they make. And I could have hypothesis. I could word it two ways. If someone had a rough childhood, they will be less likely to be financially successful than someone who did not have a rough childhood. Or, still a prediction, people who had rough childhoods are less likely to be financially successful than people who did not. See that prediction? I'm predicting a relationship between two variables. It's testable, it's prediction, and I can define my variables and actually test it and see if it's true or false, or actually what we say is supported by the evidence or not supported by the evidence. Now, this is one thing I want to be careful about. I see a lot of hypotheses where people will stick extra stuff in there. So either one of those, you could say people who had rough childhoods are less likely to be financially successful than people who did not because their parents did not teach them good money skills. Now that's entirely possible, but you can't really look at that unless you ask them about money skills. And then how do you figure out the relationship between all three variables? So for your studies, I want you to keep them very, very clean. Two variables, prediction. Don't stick anything else in there, because when you stick anything else in there, it makes your hypothesis not testable. We'd have to posit a very complicated relationships about money skills, about how their parents taught them money skills, etc. So keep that part out. Prediction of relationship, very short, straightforward, simple prediction of a relationship between two variables. And I will see you guys next week.